This begins the technical part of the EarthRadio DVD. So here we go. Okay, I didn't mention before, but this unit also has a 1/8 inch stereo jack line output connection. This connection can be used with a line output cable of the typical kind that comes with your portable CD players, where you have the 1/8 inch mini plug on one end, right here. See if we can get a good shot of that. Okay, I think you can see, yeah, there we go. See, it's a 3-conductor plug. This one's homemade, but it still illustrates the concept pretty well. So we have a mini plug, 1/8 inch stereo mini plug, and coming out to 2 RCA plugs. If you want to capture files into a computer, you can usually find audio ripping software on the internet. You can use a cable with a 1/8 inch stereo mini plug on each end and connect this directly to the line input to the sound card in your computer, and it'll rip magnificent files of natural radio sounds just off of this loop. So let's pause here and we'll go over the loop and show you which directions are sensitive. Okay, now we're looking through the aperture of the loop. The aperture or opening of the loop is the area that's sensitive to magnetic lines of force as they go through the aperture in that direction. Now, a magnetic object, like say if I were banging this screwdriver against pliers, you would hear the response if it was held here. That's because the magnetic field is nearby and it would be going through here. For a distant or far field event like a lightning strike is very much the same as a vertical conductor of wire, and we use this pill bottle as a model. Okay, a lightning strike will actually be received best by the loop when it's 90 degrees to the aperture. The reason for that is far field or distant from the lightning strike, the effects are as follows. The magnetic waves come out in rings, very much like water waves as a rock or pebbles dropped into a pond. Ever increasing circles, and of course eventually one of those ever increasing size circles comes through the loop. So as these magnetic waves go away from the lightning strike, which is essentially just a vertical conductor carrying a lot of current, the waves are coming out in rings, and they get bigger and bigger as you get further, and eventually they go through the aperture of the loop. That's why far field lightning strike, you'll receive it at 90 degrees from the loop's aperture. Another feature of this system I might as well bring up at this point is that, as you can tell by the banana plug, and both connections are the same, the input circuit of the receiver and the loop are wired as what we call balanced low impedance. Balanced means that whatever signal is applied to one pin has to be equally opposed by a signal of the opposite polarity on the other pin in order for the amplifier to see a signal. So what that means is that any hum or noise picked up by this unshielded cable, since both wires are right next to each other, essentially the same noise signals appear on both pins, and they're in step or in phase with each other, so they cancel almost completely. They give a delightful amount of noise immunity without having to use expensive shielded cable. And likewise, if you want to run a long cable to a sensor outdoors a good distance from the house, you really don't have to worry much about hum pickup. Balanced low impedance is a technique that the telephone company has used for a century or more. It's simple and it works. While this is also the same basic structure, cabinet, and insides that you saw on the Part 3 demo, I had to radically modify it in order for it to even function. Before we had the power supply here, the input transformer of the amplifier was here, there was no way that I could shield or humbuck the noise out of the system.
Are you talking to me?
So I had to cut the circuit board and then move the input transformer down here, and I took the power supply out of its shell and moved it up here. So now they're on opposing corners as far apart as I can get them within the cabinet. Now another thing that helped is the original Radio Shack transformer that most of those little cutie boards use is an output transformer. It has no shielding or no provision to reduce noise pickup. I had to go to a much more expensive transformer. While the Radio Shack transformer was $4, this wideband telecommunications transformer from Tamara, which is available through Mauser, it's part number MET17. This transformer is about $16, and the mu metal shield that goes over it is about another $7. It's kind of pricey, but it offers a very accurate, very repeatable, and very scientifically measurable frequency response, and the reduced noise pickup makes it well worth the extra money in this application. It did totally eliminate the hum problem. The board is basically the same except for the transformer part of the front end cut off and moved down here. It's connected by a piece of shielded miniature coax. See the back of the banana jacks. The AC input, the terminals are now heavily insulated, and the power supply insides are here. And that's pretty much the inner view, inside view. Might as well go ahead and show the detail of the speaker. Speaker holes look like they were made by a drunk person with attention deficit disorder, but they're fairly open and let most of the sound through. And as you saw before, the grill covering over the front hides the mess. And basically we have all the sound coming out through this pretty transparent opening and still have a nice handsome front on it. And like in the part 1 little cutie demo, everything on the main board is pretty much the same, other than the fact that the transformer was moved down here. The resistors here, they started out as a 100K, and because they didn't have enough stiffness, or they had too much resistance to effectively, oh my, talking about resistors and you can't even see there. Okay, oh, this is funny. Okay, little cutie board, same thing as part 1 demo. Transformer down here, heavily insulated AC input. You can open this thing up and be in it without any danger of shock hazard. Same thing about the connections up here on the power supply. And the back of the banana jacks, I think we got everything. Line output jack back here. That probably pretty well does it. I have to keep each of these segments down to 10 minutes so I can upload to YouTube. But that shows everything pretty clearly. Got a big picture that fills the whole monitor. The Kobe Tone speaker sounds like a champ. Does a great job of reproducing the high frequency earth sounds. And I think I'll call that it. This is awful trying to remember all this stuff, but I don't think I have any more technical information. We went through the loop and which directions were sensitive, and I think that pretty much does it. The next part of this will be where I actually take line output audio from this thing, and I'm going to feed it to the left channel of the DVD recorder and do the mic on the right like we did for the part 3 demo. And it will be very, very sweet because there will be a sharply reduced amount of hum this time. So stand by and watch the next part of this. It'll be nice.